So coming back to what we have done so far, we have learned a lot of things. Okay, let me make it a full screen. We went ahead and created these two tables so far. So if I execute them, query and execute, these are the two tables and the values they contains. Okay, there are around 10 rows that employee table contains, and there are around 3 rows that the branch table contains. All right, so which means if you look at the entity and the attributes, these are the two tables that we have created so far. So what we are going to do today is, let's go ahead and add a couple of tables again, and later we'll try to understand what is known as joins today. It's a very interesting concepts of joins in SQL, and also we'll also learn about some of the other queries or commands as a part of the SQL. All right. So let's go ahead and create what is known as a customer entity or a customer table, which contains these three attributes. All right. So what is this customer? Customer, let's go ahead and create a table. For that, we need to use a command called create table, and the table name is customer because that is what we have here. This is the table name, which is nothing but the entity name. And then this table contains these three attributes, and these three attributes will become the column names. So let's go ahead and create this column name called customer ID. It would be a primary key. All right. So let's go. Let's say, what is this I have? Let me copy that. Customer ID. And this customer ID would be of int data type, and it would be a primary key. Primary key. All right. And then what else we have got? We have the customer name. Customer name, obviously, it's a varchar, and we'll go ahead and create a customer name. Customer name, and this would be a varchar of, let's say, 32, and let this be not null. And this is again a constraint that I'm adding. And then we're going to add, next is branch ID. Branch ID, and this branch ID would be of int data type. All right. So I'll go ahead and create the primary key. We have already have the primary key, but at the same time, we also have this branch key as a foreign key. And this foreign key will be linking to the primary key because this is the references that we need to give, right? The references from the branch table, the branch ID. Let's go ahead and create that. So how do we create that? We create that using what is known as a SQL constraint called foreign key. Foreign key. And that foreign key is nothing but your branch ID, which is part of this table, what we have been creating here. This would become a foreign key. And this foreign key will references which table? Branch table. Branch table. Inside that, there is a column or an attribute called branch ID. Branch ID. And then let's say on delete, we want to set it as null. Set null. All right. So next, I'm going to close this. That's it. So we are creating a table called customer, which has got a customer ID, int, primary key, then customer name, varchar, which is not null. Then there is a branch ID, which is of integer data type. We are setting a foreign key, which is a branch ID, and then it references the branch table. Inside that, there is a column called branch ID, and on delete, we are setting that to null. Let's go ahead and execute this. So command completed successfully, which means this table has been created. So if I go ahead and see this table, I'll be able to see customer table. Query execute. So I have got these three rows, these three columns that have been created because of this create command. And the next what I'm going to do is we have the customer table created. Let's go ahead and create what is known as, let's say, vendor table. Okay. Or employee assignment table, whatever you can go ahead and create. Let's create a vendor table first. So for that, what we need, again, create table called vendor. Okay. And this vendor table again will contain, there are certain set of columns, right? What branch ID, vendor name, and supply type. So what kind of a material they are supplying, like pen, paper, pencil, or whatever the stationery that is needed for the company. So let's say branch ID, which is of the integer data type. And let's say int. And then what we'll do, we'll have a vendor name. This would be of varchar. Let's say this also as 32. And then supply types. And this supply type would contain what? Would contain, this also might be a varchar. Okay, then this also with a 32. And then we have a primary key also set, right? The primary key is this branch ID, and this also becomes the foreign key. And this foreign key is referencing again the branch. Okay, we need to set that. And then there is a combination of primary key, which means the combination of branch ID and vendor name together will become a primary key. Earlier, what we have observed is only one column name is getting a primary key. Here, the combination of these two columns will be a primary key, whereas the branch ID is also acting as a foreign key. All right. So we will set that now. Let's go ahead. So how do we do that? For that, we need to set a constraint called primary key, because there are two we need to use, right? Two columns. So for that, we are going to use primary key. And inside this primary key, what I can go ahead and give, let's say branch ID, comma, there is another, that is vendor name. So together they will become a primary key. All right. This is again a primary key constraint that we have created. Next is, let's create a foreign key for the branch ID. Foreign key, and that foreign key would be for branch ID. This one that we have used, branch ID, will be the foreign key. And this foreign key will references REFERENCES, references what? Branch table. Inside that there is a branch ID column. All right. And on delete, I want to not set it as null. I want to just cascade it. So now, what is the difference between on delete or set as not null, set as null, and on delete set as cascade? What it means is whenever the primary key, which is from the branch, there is a branch ID, right? Whenever this parent or the primary key is deleted, then the corresponding foreign key value that is present here should also be deleted. That is what the cascade is. So this branch table with the branch ID is nothing but this will be a parent, whereas vendor will become the child. Whenever the foreign key is set, the foreign key where it resides, which is in this case the vendor table. This table will become the child, whereas the branch table is always the parent. Whenever the parent key is deleted, okay, whenever there is a row that exists in the branch, and this row, if we delete it, then automatically a row corresponding to that in the child table, which is a vendor table, should be deleted. That is what cascade means. Whenever it is set null, which means whenever branch id is deleted, then this branch id in the vendor table will be set to the null value. That is what it means. Okay. Now let's go ahead. Yeah, here this is something. I can go ahead and close this table. All right. So there is a vendor table, which is a branch ID, int, vendor name, varchar 30, then supply type, then primary key is set to the combination of these two. All right. And the foreign key is branch ID, only this ID, which references the branch. All right. This looks good. Let's go ahead and execute this. So command created successfully. Then let's go ahead and see vendor. Now, currently there are no rows. We will go ahead and add those, but only we are going to see the three columns have been created. All right. Now, at the last, what we are going to do is we are going to create this employee assignment where we have an employee ID and the customer, which means this is basically an assignment table where if the company has got 10 employees, let's say all the employees, like each employee, they are working for which customer. Okay, that is what the assignment we are going to do here. Also, we are going to have the combination of these two as a primary key, and there is no foreign key as such. Let's go ahead and build this employee assignment. Let's say create table employee assignment. Then what we have something called as what, let's say employee ID, customer ID, and total sales. Okay, let's say employee ID, which will be of int data type, obviously. And then there is customer ID, which is also of the int data type. And then there is again, we have total sales, right? So total sales in related to that customer, total sales, and this will also be of int data type. Now we need to set the primary key, right? The first two, these two are setting as a primary key. For that, we'll set a constraint called primary, primary key, and this will contain emp id, comma, customer id. All right, these two combination will become the primary key. So the assignment table, which contains employee ID, customer ID, and total sales, all of the integer data types, and the primary keys, the combination of these two will be the primary key. Let's go ahead and execute that. Yeah, command executed successfully. And now let's say select star from assignment. All right. So if I go ahead and execute this particular SQL statement, we have got three columns that have been created as specified in this table. So what we have done so far is we have created all these five tables now, and these two tables have got the data into it, but these three tables are still empty. So what I'm going to do is I'm going to insert the values there. So for that, I have already created some listing here. So just added that for the ease of our operation here. So what I'm going to do is, let's say into the branch I want to add. So what is this branch? Now how to uncomment it? The shortcut is Control KU, uncomment it. So what I'm going to do, inside the vendor table, I am inserting the values, three values. What are these three values for the vendor table? The branch ID, vendor name, and the supply type. So the branch ID is 102. The What is that vendor name? Is a Kokuyo Camlin company, and they are supplying, the item is papers. And then there is Hindustan Pencils, they are supplying pencils. And then Archie's, they are supplying the writing pads. And Navneet is again a company, a vendor company, that is supplying pens for the organization. So let's go ahead and execute all these and see what happens. So all have been executed. Let's go ahead and see. ELECT select star from vendor. Okay, so what this will do is, it should have went ahead and created these three, yeah, 6 rows. Execute. Yeah, what we can observe here is all these have been created as per the insert statement. Next, what I'm going to do is, I'm going to enter the values for the customer table that we have created, that is control KU, uncomment it. And now what it contains, customer table, let's go ahead and see. Customer table contains customer ID, customer name, and the branch ID. So here, what it contains for us, customer ID, which is 501, customer name, which is Cisco, and for which branch this belongs to. Okay, the customer, which branch in the employee table that we have, branch table that we have created, right? So that is 102, which belongs to Pune, 103, which belongs to Hyderabad. Okay, these are the two branches that have created, and one was 101 belongs to the head office. If you observe it here, or let's go ahead and see, execute the branch itself. Yeah, if I execute this, we will going to see. So these are the three branch IDs that we have created: 101, 102, and 103. Head office, Pune and Hyderabad. This is what we are assigning them. So let's go ahead and execute this all queries. Execute. So all have been affected. Now let's go ahead and execute customer. And this customer contains these 6 rows that we have inserted just now. All right. And finally, we are going to add the last table that we have created today, which is employee assignment. And let me go ahead and uncomment it. Control KU for shortcut. Again, guys, this is one way to do is add dash dash. Another way to do is multi-line comment. You can go front slash star and close that by asterisk back front slash. Okay, this is also another way to do multi-line comment. Okay, one way is using dash dash, and another way is forward slash followed by asterisk, and then end it by asterisk forward slash, like the way we do it in CSS, right? It's the same. All right. So now what this assignment table contains, employee assignment table contains employee ID, customer ID, and total sales. Okay. So that is what we are going to do. Employee ID, and this is the customer ID, and this will be the total sales value. All right. So let's go ahead and execute all these queries to insert the rows in the table. And let's say EMP assignment, how many rows that we have inserted? We have inserted total 9 rows, okay, through that column. All right, so this is a good start. Now that we have created all the tables, and all the tables have got certain values inserted to them. Now, with that being said, what we are going to do next is, let's understand what is known as joins. All right, let me go back here. This is an important concept here, guys. Just try to concentrate, because joins are very crucial in understanding SQL. So what are these joins? Joins are basically, as the name itself suggests, like join means you are combining some more than one or two values. Okay, so adding the data of two, no more than two. That is what you are combining it. All right, join means to combine, right? So it is used to combine data from two or more tables, all right, based on certain common column. All right, and what is this will do, it will result into a single set of values, which is based on the conditions on which that we have joined the table. What it means is, there is a table A and there is a table B, or table 1 and 2. we and the common table or a similar column exists between the two tables, let's say employee ID, okay, which exists between two columns, and we can combine them. Like for example here, uh, let me go to the query, and let's see, select star from employee. All right, this is one table. Then another table I can do is employee assignment. If I execute these two queries, what I want to show it to you here is these two are separate distinct tables. Okay, these two tables have got a common table or column called employee ID. The employee table contains employee ID, and there is also an employee ID present in the employee assignment table. Now I want to join these two columns, because if I take the first table, it does not have the customer ID here. Okay. But the table 2 contains the customer ID. What I need is I want to create a different set of output result where I am trying to find employee ID, first name, last name, and the customer they are assigned to. Like for example, these are the customer IDs. Okay. So I need to find that. And how can I do that? This problem can be solved better using the joins. All right. So let's take the different kinds of joins that we have to understand. The first one is called inner join. All right. What is this inner join says? If these two circles, okay, these two circles represents two tables, okay, and the intersection part, what is highlighted here is what is known as inner join. This is the resultant. This is common, or the intersection set. The first set and second set, there are two set of tables, and the common between those two tables is given by inner join. So only the things that match on the left and the right, which is left and the right. Like for example, just if you observe the pseudo code here, select star from table 1, inner join. Okay, this is the a command that you need to understand, inner join. And what this inner join says, the first table and second table based on this key. The key in our example is employee ID, because that is the common for both the tables, right? So employee ID we can use and join them. All right, let's see that with some example here. So what I can do, let's go to our query. Here I'm going to execute a query. Let's say, what is that? Let's say select employee. Now, understand that when I'm selecting, right, I need to select employee ID of employee table. So how do I do that association? I can do that using table name dot column name. Okay, that is what I'm saying. I'm saying, select the employee ID from the table employee, okay, which is this table. I need to select this, and let's say I want to select again one more MPL employee dot first name, and let's say employee dot last name. So these are the three columns that I'm selecting it from the first table, which is employee table. And also what I need to do is I need to find the customer that they are assigned to, right? Then I need to select this customer ID. So what is this customer ID? This is part of employee assignment table. So I need to do employee assignment dot customer ID. So this is the way that I have selected four columns of two different tables. All right. So now this is what I am selecting from where? Employee table. Employee table. But what I'm trying to do here, I'm trying to do the inner join. Okay. I'm trying to do the inner join, which is nothing but inner join on what? Inner join on the table, the right of it. Okay, this is the left table, we have an employee, and the right table we need to take employee assignment. This is the employee assignment. Inner join on this table. All right. Now, what is the key that we need to select? Because we need to select this key as well, right? On what key that we are comparing these two tables on, or joining these two tables, which is on employee.employee ID is equal to employee assignment dot employee ID. So what we are trying to compare here, this employee ID and this employee ID. All right. So now if you compare these two employee IDs, right, we need to select only the ones that are common. So in this common are all of them. So except 10,000 and 10,001, these two columns are not there. Keys are not there in the employee assignment. Employee assignment starts from where? 1002 all the way to 1010. Whereas this table, employee table, contains 10,000, 10,001 all the way to 10,009. It does not contain 10,010. So what is the common between these two? The common is right from 10,002 all the way to 10,003. These are the columns that we see them as common. 1,002, 3, 4, 5, 6, 7, 8 all the way to 9. 10 is not there in employee table. Okay, it just contains 109. So the common ones will be shown now. Let's go ahead and execute this particular query, which is inner join. Inner join is always common. So if you observe that, it contains employee ID, which is here, employee first name, which is there, last name, which is also there, and then there is a customer ID, which is also there. Now if you observe, 10,000 and 10,001 is not shown here, because that is not inner join, that is not common, because we only will get the match that is there on the left and right, so which is there into the common intersection set only will be shown here. So this is what we call it as inner join. All right. So you are joining two tables on this particular key, and you are getting this result, and that can be done using inner join. Let's go ahead and find what is known as left join. Okay. So what is this left join? There are two tables, employee table and employee assignment table. In our case, in the example that we referred to, what left join will do? Everything on the left table, okay, which is everything on the employee table, that is our left table, plus anything on the right table that matches, okay, which is intersection. All right. So the intersection set as well as everything on the left. Okay, that will be your left join. Or in simple, if I say left join, which is simply telling that everything that is there on your left join. Okay, table, which is in our case, the left table is employee table. This is the table. Let's copy this. Nothing changes except what? Except the left join. What I'm trying to do, I'm comparing, selecting all these four columns from the employee table, left joining the employee assignment table on employee ID and employee assignment. Now understand that if I go ahead and see this table, so what the left join is on the employee. So employee is on your left. So everything that employee has, which is all the way from 10,000 to 10,009, all of these will be there. But the one like 10,000 and 10,001 does not exist in the branch table, does not exist in the employee assignment table. So for that, the employee ID will be set to null. Okay, so because it will include everything that is there on the left side of the table, which is of the employee table. But for those which it does not find the corresponding value of the employee customer ID, which is in this case 10,000 and 10,001, that does not exist in the employee assignment. For those, the employee customer ID will be set to null. Let's go ahead and execute this and let's observe that. So if you observe this, guys, the customer ID for 10,000 and 10,001 is set to null, but for rest of them until 10,009, the values exist in the employee assignment table for the customer ID. So it populates rightly. All right. But for 10,000 and 10,001 employee ID, there is no customer ID existing in the employee assignment table. That means this value will be assigned a null value. All right, this is for the left join. You can also give it as, sometimes left join can also be called as left outer join as well. This is also means the same, nothing, no difference here. You can say left join or left outer join, both means the same. All right, so there is nothing difference in it, and that is how it will be. All right, no changes. All right. Now, there is a slight difference between left join and anti-left join. So, anti-left join is only the left part of your table, which is employee table, but not the common ones. Common ones are ignored. How are you going to do? Whenever this value is null, where condition is null. So, you are not going to take that. If the where employee ID is equal to null, then you are going to not consider, that is not on the right. All right, that is the null, because if you observe this, what you see, this value, right, this is what you are going to see, not the everything, because these are all the common, right, both will contains, like this, let's say air, air employee assignment is. So if you observe 10,000 and 10,001, these are the values that won't be selected. These are the values that will be selected for this one, anti-left join, which means they are only present in the employee table, but not in the employee assignment table. All right, that is what we saw. All right, so this is again anti-left join. So there is no change in the keyword left join. This is still remains the same. Only thing is we are going to add a wait clause where from the right table we are assigning is null. So wherever the employee ID is null for them, we are throwing those rows. All right, this is called as left join. In the same way, we also have what is known as right join. As we have the left join, it is just opposite of the left join, that is the right join. So everything on the right, which is the employee assignment table, in our case this table, everything on the right table plus anything on the left that matches, which is the common. So in simple, if you say the right join contains all the rows that are present in the right side of the table, right side of the join, that is called the right join. So what it contains is, if I go ahead and copy this, nothing changes except for the keyword. Instead of left, it will be right. That's all. Now, before we see that, let's go ahead and execute this. So let's observe that. What are the tables that are present in the right? These are the ones which is from 10,002 all the way to 10,010. Whereas 10,010, right, this employee ID does not exist in the employee table. So for this, the value will be added as null. Okay, because it just contains 10,009 only. So all the way from what you are going to see, you are going to see from 10,000, 10,002 to all the way 10,010. but 10,010 employee ID will be added as null if I execute this. So if you observe here, these values are null. Why? Why? Because the employee assignment table, which is the right side of the table, only which contains 10,010, right? That is what it contains. But the employee table does not contain 10,010 employee ID. So that is the reason you will see all these three values as null, whereas the customer ID is picked up from the employee assignment table. If I go ahead and just execute this, let's say if I go ahead and select and execute these two queries, we'll be able to see. So if you observe this, guys, why this 9 is having all the three null? Because this is taking from this table. 10,010 exists in the employee assignment table but does not exist in the employee table. Hence, the corresponding values for employee ID, first name and last name are null. That is the reason you are showing them as null in this particular query. Okay, so this is called the right join or the right outer join. Both means the same. Again, you can go ahead and add this clause as well, where the employee assignment is again null. That will be anti-right join. Okay, so that is the anti-right join. Is absolutely fine. Then the next is the outer join. So outer join is what? It contains everything on the right, everything on the left. So you take both of them, that will be the outer join. So yeah, outer joins, outer join, sometimes it is not there in your SQL server, but it can be used in MySQL database. But for this, what we can say is full join. Okay, full join is a better way to do it. Just use the full join and then execute it. That should be good. Yeah, if you see this full join, what it contains all the rows from the employee table, all the way from 10,000 to 10,009. Okay, they contains, but employee assignment table contains the additional, which is 10,010, right? Which is that row is also added. So these two are added null because employee assignment table does not contain these two. Okay, 10,000 and 10,002 as an employee ID is not existing in the assignment table. Hence, the customer IDs for them is set to null. Whereas the employee table does not contain 10,010 value. Hence, all these three are added as null. Whereas employee assignment table contains the 10,010. Hence, the customer ID from that is picked and it has added, and rest of the values is set to null. This is called full join, or also known as outer join as well. Okay, it both means the same. You are going to take everything that is there on the right as well as the left, which is employee and the employee assignment table. And finally, there is also something called as cross join. Cross join is what? It's a combination of all the rows from the right table and the left table. It is basically a Cartesian product. In this case, you will have the same thing, where employee first name last name, then 501, employee first name last name 502. So all the combinations, Cartesian products. Okay, that is what will be your what we know, what we call it as cross join. Cross join is the Cartesian product, which is containing all the rows and all the columns and the product of it. Let's see that example so that you understand it better. So what we call this as a cross join. Was join on this employee assignment. You don't need on for it. Okay, cross join does not need a on. You just need employee, select what columns you want to select from the table employee, cross join the employee assignment. That's it. If you execute this, it will give the all the combination. Like for example, 10,000 Rohit Patil 501, and there will also be a 10,000 which will be Rohit Patil 502, and then there will be 503 as well. 503 is what you see here, and there will be 10,000 Rohit Patil 502. In the same case, like the second one, 10,001 Fatima Abdul 501. There will be 10,001 Fatima Abdul 502, 10,001 Fatima Abdul 503. All the three values will be there. The next one is this 503, and then finally Fatima Abdul 502. So in this way, it will be a Cartesian products of all the values that you can observe. Okay, a total of 90 rows will be created. Okay, so this is what we call it as cross join. Okay, cross join is the Cartesian product of both the tables. All right, it is basically all combinations. This is the key, all combinations of rows from the right and the left table. Okay, so these are something that we need to take care of why we are talking about joins in SQL. All right. Okay. So the next thing what I want to show it to you is about a statement called group by. Okay, we have seen order by, right? Order by is all about sorting. And now what we are going to look at is something called as group by. So what is this group by? Group by statement groups the rows. Okay, they group the rows that have the same value in the summary rows. So what I meant by that is, uh, whenever we use the group by, right, it is often used with the functions like max, min, sum, average, and all that. Let's take this as an example. So if we observe this particular table, this is what employee table select. So what we are seeing here is there are 10 rows that it contains. And these 10 rows, if I want to find the salary of the employees that are there in the branch 101, okay, and I want to group them by the branch ID. So what is that? If I want to group them by the branch ID, I want to see the total salary that each branch we are providing. So like 101, 101, these are the two values that we have for the same branch. Okay, 101 branch, we have two rows, which is 10,001 and 10,000 and 10,002 employees, which is Rohit and Fatima, both belong to 101 branch. And if we sum their salary, it will amount to a certain value. And again, 102, 102, 102, 102. There are four values for 102 and 1, 2, 3, 4 values for 103. I want to group them by those branch IDs and give the salary of what is the total salary by the branch ID. Let's do that. How we can, if we solve this, this can be done by group by. Let's talk about this. If I execute this query, you will be able to understand it much better. Let's say select, let's say I want to select the sum of the salaries by branch, right? Let's say I'll select the sum of salary, which is this column, sum of salary, comma, let's say branch ID, and these two, what we call these two columns that I wanted to select from what? From employee table, okay? From employee table, and I want to group them. So what is the clause that I'm going to use? That is group by. These are the keywords, group by branch ID. What it means, 101, 101. So these two rows, I want to group them and sum this salary and show. And again, next is 102, 102, 102. All the four values grouped by this branch ID 102, and sum of all those salaries of 102 branch. I'll sum it up and have that stored in this column. And then so is the case with 103. So I am grouping them by the branch ID. All right. So once I do this, and let's say if I execute it, all right, let's say I'll execute, let's say I'll execute only this. Let's see, execute. So what you observe here, guys, 101, 102, 103, because that is what I'm grouping by. If I observe these two, let's say I'll put this here so that I can compare them both side by side and show you, right? Let's say I'll execute these two queries. Execute. So now just observe this. What is that I'm doing? I'm selecting the sum salary. Maybe I can give this as what I can give. I'll give some alias as, because this now contains no column name, right? Let me give this as salary by branch. That is what it is, right? So it is a salary that is given by the branch. Let's go ahead and execute it both. So it will be salary by branch. So just observe this. So what is that group by is trying to do? If you observe 101, 101, there are two rows that we have. Okay. So the two rows are grouped by the branch ID, which is 101. Now, if you sum these two salary, because that is what the salary sum is, which is what is this, which is contains 11 million and 5.5 million. These two, if you sum it up, it will amount to what? This value, which is 16.5 million. All right. And then 102, if you observe, there are four 102s. And if we add four, what is this? 4.5 million, and this is 3.3 million, 3 million, and 2.5 million. All these four, if we combine, it is amounting to 13.3 million, which is the salary that is given in the branch 102. And so is the case with the branch ID 103. We are giving 13.3 million as the total salary that is given to the employees in that branch. And this is how you do the group by. All right. And again, you can also sort them as well. How do we do group by? And then you can give as order by as well. Order by, let's say, how do you want to order them? Let's say I want to order them by the salary. Some, or let's say this one, some salary. I want to sort it. Sort it what? Let's say sort it by ascending order, which is smaller first and larger. Then we give the larger one. So the first, second, and then it will be third. All right. Let's go ahead and execute that. So it is sorted by the sum of the salary. So the first one is this, second, and then this is the third, ascending order. All right. So you can combine these clauses like group by, branch ID, and order by, and that will give you this particular clause. All right. So now, if we observe this, let's say there is another, if we jump on to the another one, right, which is known as having clause. Okay. There is another clause or the statement that we can use, what is known as having. Okay. Which is nothing but having clause or a having keyword. And this keyword is basically similar to where clause. Okay. But where clause has got certain restriction. Where clause cannot be used with aggregated functions, like for example aggregated functions like sum function or min, max, and all those are called aggregated functions, right? And if we want to use a where clause for the aggregated functions, you cannot use it. That is the reason we need to use the having clause. Okay. Now let me give you one example here. So let's go ahead and let's say we are going to use having clause. All right. So this we have used as a group by, right? Group by clause. And then we are going to use next is having clause. Let's see. Select the same thing. Let's say salary and the branch ID. Let's say this one. We are going to select the sum. Sum is again an aggregated function in SQL. I'm selecting the sum of the salary by branch alias I have set and the branch ID. And from the table, again, the same employee table, from the table employee. And what I'm going to do, let's say, where sum of salary sum of salary is let's say greater than 5 million. So what is that greater than 5 million, or let's say greater than 13.5 million, 13.3 million, greater than 13.3 million. All right. So this is one, this is, yeah. All right, this is 13.3 million. So if I execute this, what should happen? I should only be getting this value. All right. Or yeah, even I can say group by as well. Let's say, because we need to group by as well, right? Branch ID, group by, let's say branch ID. All right. So now what is this I'm trying to do? So I'm selecting the sum and salary of the sum of the salary and the branch ID from the employee table, where I'm saying a sum of the salary is greater than 13.3 million, which is only this value it should be shown. Okay, that is what we are trying to execute out of this. Now just observe the error here. So what will happen? It will throw this error: aggregate may not appear in the where clause. Okay, where clause cannot use the aggregate function as the condition. You can use other things like date of joining and all that, you can use, but you cannot use the aggregate functions like sum, average, or min, max. You cannot use it in the where clause. For that, you need to use having clause. So having clause is kind of a where clause where you are allowed to use the aggregate functions like what we have seen here. So the same statement, what I can do is I can make a slight change here. What I can make a change, let's say from the table, you are going to say group by, then I can say having simple group by the branch ID having sum of salary greater than 3.3 million. If I execute it, it will be executed absolutely fine with the same condition, but the change here is instead of where clause, I am going to use having clause. Okay, from employee having sum of salary greater than 13.3, which is nothing but only one value we had in the table. If we just execute this, you have got three rows, but I am setting this having clause. If I execute it, only the first one, which is from the branch 101, is 16.5 million, which is greater than 13.33 million. So it will only show one particular row. All right.